హాయ్ ఇంజనీర్స్. ఈరోజు మనం ఇంజనీరింగ్ ఫిజిక్స్ జేఎన్టీయు హైదరాబాద్ యాజ్ వెల్ యాజ్ ఏఎన్ఆర్కే సిలబస్ R25 లో ఇంపార్టెంట్ క్వశ్చన్స్ అనేవి డిస్కస్ చేద్దాం. రైట్, బేస్డ్ ఆన్ ప్రీవియస్ ఎగ్జామ్ పేపర్స్ ఏవైతే క్వశ్చన్స్ మనం డిస్కస్ చేయబోతున్నామో అవి అనేవి నంబర్ ఆఫ్ టైమ్స్ రిపీట్ అయినాయి. సో ఈ సిలబస్ వచ్చేసి అటానమస్ కాలేజెస్ కి జేఎన్టీయు హైదరాబాద్ కి కొద్ది వేరియేషన్ ఉంటుంది. బేస్డ్ ఆన్ యువర్ కాలేజ్ యూ కెన్ చెక్. సో when come to ANRK, we have first unit as quantum mechanics, which includes solids as well. Second unit, we have semiconductor physics and nanotechnology. When come to third unit, we have quantum computing. Then when come to the fourth unit, we have dielectric materials and magnetic materials. When come to fifth unit, we have lasers and optical fibers. సో మీరు ప్రిపేర్ అయ్యేటప్పుడు బేసికల్ గా చేయాల్సిన పని ఏంటంటే you have to cross check the total syllabus. Right, now we will go for the exam pattern, especially for sem end, that too R25 regulations. This pattern is common for all theory papers for R25 regulations. So the question paper consists of two parts, part A and part B. So part A లో వచ్చేసి 5 క్వశ్చన్స్ ఉంటాయి. Each question carries 2 marks. 5 2s are 10 marks. When come to part B, we have to write 5 questions. Each carries 10 marks. That gives 50 marks. So total marks per semester exam is 60 marks per out of 100, whereas part E is for internal. Right, in part A, we have 5 questions, each question from one unit. Unit 1 questions, 2, 3, 4, 5. 5 questions will be there. There is no internal choice. 5 questions we have to write. When come to the second part, we have internal choice. From 5 units, we will get 5 questions. So 6 or 7, 8 or 9, 10 or 11, 12 or 30, 14 or 50. So these 5 questions we will get. This is from unit 1, this is from unit 2, this is from unit 3, this is from unit 4 and unit 5. Right, according to it we have to prepare. If we go more deeper into this pattern, so generally the part B we can selectively read rather than going to all the questions. So question number 6 we will get from quantum mechanics syllabus, and question number 7 we have the part of solids in the quantum mechanics itself. When come to 8th question, generally we will get from semiconductor physics, or 9th questions we will get from nanotechnology. Then 10th question we will get from first part of the quantum computing, where generally we will cover for mid-1 exam. It's a quantum computing. 10th also quantum computing part 2, which we prepared for mid-2. This is from part 1. Then 12th question we will get from dielectric materials, or 13 from magnetic materials. Then 14 from lasers. 15th question from optical fibers. So whenever we are preparing for the semester end exams, only we have to write the 5 questions. It means that from 6 or 7 we have to write 1, 8 or 9 we have to write 1, 10 or 11 we have to write 1, 12 or 13 we have to write 1, 14 or 15 we have to write 1. So overall 5 questions we have to write. So based on your comfortability and convenience, you can read one part of the questions if you have the less time. If you have the full time, then it's always advisable to read complete syllabus. If you have a short span of the time or you want to revise quickly, then it's a better to not to read everything. Selectively you can read based on your preference. Now we will go for question wise. So rather than going question wise, we will go by unit wise. So unit 1 quantum physics, and when you prepare in this order that may be good. So first you can go for Kronig-Penney model, second one time independent Schrodinger wave equation, third one-dimensional box, fourth one formation of bands and classification of solids based on the bands. Then fifth one is Davison-Germer experiment. Right, so in this, from these 2 generally we will get 1, and from these 3, 2, 3, 5 we will get 1. because we have to write the only one question from unit 1. Now we will go for unit 2. Unit 2, we have two parts. Part A is semiconductor physics and part B is nanotechnology. So even though these two are very important concepts and in the exams we will get a repeated questions. So semiconductor physics, generally we have PN junction diode on first priority, formation of PN junction diode, then forward bias, reverse bias. That's nothing but the IV characteristics, current voltage characteristics of a PN junction diode. Next one is Hall coefficient. So the experimental procedure, sometimes they will ask the derivation for Hall coefficient. Then when come to the next one in this category, mostly we will get solar cell. If we won't get those two, the third one they will prefer is solar cell. On rare occasions, very rare occasions, we will get LED. So when come to the nanotechnology, we have the synthesis method, sol gel process. Generally, they ask and highly preferred. Then scanning electron microscope. It's a characterization technique. If those two are not given, then the examiner may go for ball milling. And rare occasions, they will ask XRD. Right now, this is about unit 2. So whenever you are preparing, go in the same order. Right. Next, if we go for unit 3, that's a quantum computing. So it's a single unit, but when you prepare, start with quantum gates. This is the high priority one. So quantum gates, what are the single gate, multi-qubit gates and single qubit gates? Those things you have to know. It's a truth table, what is its significance and all. Then comes Dirac's bracket notation. Dirac bracket notation and its properties. Then third one is quantum information processing system. Quantum information processing system. How the quantum information is processed in the quantum computers. Then comes challenges and advantages of quantum computing over classical computing. Next one, we can expect qubits and its properties. There is a two key concepts related to qubits, that may be superposition and quantum entanglement, but most of the time they may be asked as a short questions based on the syllabus, right? So this is about the third unit. When come to the fourth unit, Unit 4, we have two parts. One is dielectric materials, second one is magnetic materials. So in this dielectrics, what we will get is, generally we will get the types of polarizations. Explain the types of the polarizations in dielectrics, and in that sometimes we may get the derivations related to, otherwise we may get the classification of the dielectrics like piezo, pyro and ferro electric materials. So they may ask, explain piezo, pyro, ferroelectric materials and its properties, or they may ask differentiate between piezo, pyro, ferroelectric materials. So whenever they ask differentiate, we have to represent in the tabular form everything piezo, pyro, ferro. If they ask us explain, then separately we can explain these two. And as a safe side, it is always better to practice derivation for electric and ionic polarization. Then when come to the side of magnetic materials, in the magnetic materials also we have classification of magnetic materials based on spin. Classification of magnetic materials based on spin. So based on spin we can classify as diamagnetic material, paramagnetic material, ferromagnetic material, ferri and antiferro, right? Like this 5 types we can classify. So sometimes they may ask explain, sometimes they may ask differentiate. So whenever they ask differentiate, we have to represent in the tabular form. If they ask explain, then we have to write regular style, right? Classification of magnetic materials based on spin. So magnetic materials can be classified based on the hysteresis loop. That may be soft and hard magnetic materials. That is also one of the important one. Then we have this one, BH curve. That's a hysteresis loop. Based on this, we will classify the materials as a soft and hard magnetic materials. So if they want to ask or they are willing to ask any derivation, they will go for magnetic moment, right? Origin of magnetic moment. As a backup, you can read Weis domain theory as well, right? That is also an important concept, but as a backup, you can read. Otherwise, these 6 questions, I think, is sufficient for this unit 4. Now we will go for unit 5. So in unit 5, we have lasers as well as optical fibers. So in the lasers, the first priority is always based on our syllabus is helium neon laser. Second one, if examiner wish to give derivation, that's the Einstein coefficients and its relations. Then third one, we can have Endiag laser, which is another important one. On rare occasions, we will get a diode laser. As a backup, you can read, but give first priority to these 3. Then when come to the optical fiber, so in the optical fiber, first priority will be the derivation for acceptance angle and numerical aperture. So this is the question number of times asked. Then when come to number 2, from this classification of optical fibers based on RI, refractive index based classification, like a step index and graded index. Then third one, as a backup, you can read, we have a special applications for optical fibers for communication systems and structural health monitoring. Optical fibers as a structural health monitoring process. So like this, we can prepare. So in order to score good marks, it is not required to read everything or all the things, but what you have to do is you have to prepare selectively, but when you prepare clearly and based on the exam pattern. This is the exam pattern and the general question paper setting, but it's not a, like what we can say is it's not 100%, but 98% generally questions will come like this. So we have to always keep a backup plan if things are not go according to our plan. So this is the way you can prepare, and selectively you can read quantum mechanics or solids, semiconductor physics or nanotechnology, quantum computing part 1 or part 2, dielectric materials or magnetic material, lasers or optical fiber. Like this, selectively you can read, but whenever you are reading a part, you have to read the total part. Otherwise, my advice is at least read 5 questions from each unit. 5 5s, 25 questions minimum you have to prepare in order to get the good score. And another key points is whenever you are writing in the exam, especially diagrams matters. How you draw the diagrams carefully, representing the diagrams, that will give the good edge. Next one, equations. So derivations also good. If your mathematics are strong, then you practice derivations. If you think your mathematics are poor and you are not able to reproduce or derive the lengthy derivations, then it's better to go for theoretical concepts. And neat presentation matters. Highlight the key points. So don't write unnecessary things. Always stick to the concepts. Don't write too generic answers, and don't write unnecessary things, right? So diagrams matters, equations matters, and handwriting matters. So your handwriting will play the key role. So it's always advisable to practice good handwriting before going to exam. Don't do much strike off in exam paper, right? And I hope you can prepare well, and all the best for your exams. And if you like videos, you can share to the people or friends who can get benefit from this video, and like and subscribe. It will encourage us to do more videos for you. Thank you.